So today we'll go over the solution for the monthly math challenge of May. For the monthly math challenge of May, we are given with a grid propagation problem. So in this problem, we are given with an initial choice of selecting any three grids to be colored, and after selecting these three grids, we have to follow this four coloring rules, and we have to try to color the whole 4x4 grid. So the coloring rules are as follows. If two of the diagonals in a 2x2 subgrid are colored, then we can color the remaining two subgrids. So that is, if this diagonal is colored over here, we can color this diagonal, and if this diagonal is colored, we can color this diagonal. And the other coloring rules are, if two colored grids are separated with one uncolored grid between them, either horizontally or vertically, we can color the uncolored grid between them. So that is this one or this one. So for this problem, what we'll do is, firstly we'll try to color the whole 4x4 grid for some initial configurations. That is, firstly what we can do is, we'll select this as our initially colored grids. So while following the coloring rules, we are able to color all these grids, and after this we are at a dead end. So we can try for another configuration as well. So if it is like this and this, so we can color this one, and this one, and we are able to color this one as well, and we are able to color this one and this one, and after that we are at a dead end as well. So after trying many initial configurations, what we can see is that it seems apparently impossible for us to color the whole 4x4 grid. So now what we need to do is, we need to figure out why is it impossible. So what we can do is, firstly what we can do is, we can observe at our coloring pattern. So after looking at the coloring pattern for a while, what you will discover over here is that you will see that the coloring rule over here preserves an invariance, that is perimeter. So while following this coloring rule, the perimeter of the colored grid does not change. So you can see what I mean over here. So firstly, in the 2x2 subgrid, the color grids will be like this. So they have a perimeter of 8. After applying the coloring rule, we color these two diagonals, and after applying the coloring rule as well, the perimeter is preserved, that it remains as 8, and it will be same for both, because both are symmetric. So uh, this will be the same case for this coloring configuration as well. And in this type of configuration, we have two separated unit grids, so they have a total perimeter of 8, and if we color in between, uh, uh, the whole of this will also have a perimeter of 8, and this will be the same for this one as well. So perimeter is preserved over here. So what we can do over here is that we can claim that while following the coloring rule, the perimeter of the colored grid does not change. So since we are given with the choice of initially selecting three grids, what we can end up is that we can end up with 12 as our starting parameter of the colored grids if all the three grids are separated. So if we have three unit grids that are not joined together, we have a certain parameter of 12, and since we can't change the parameter of 12 even after applying a finite number of rules, or even if you don't apply a rule, parameter will stay as it is after we apply or don't apply the coloring rules. Secondly, we can also start off with an initial parameter of 10 if two grids are joined and one grid is separated, and we can also start off with a parameter of 8 if all the three grids are joined. So since we are starting off with 12, 10, and 8, and since we have an invariance over here, that is the parameter, we can't color the whole 4x4 grid, because the whole 4x4 grid has a total parameter of 16. So therefore, we have proved that we can't color the whole 4x4 grid, because the coloring pattern, that is the coloring rule, preserves an invariance, that is the parameter. And since we start off with the parameters, since we can only start off with the parameters 8, 10, and 12, we can never fully color the whole 4x4 grid, because it has a parameter of 16. Thank you.